This is Ashad Asif. I'm a second year MEd student in the Electrical and Computer Engineering program, and this is Group 34 for our ethics case.
Hi, this is Gayatri Kumar. I'm in my second year of Environmental Engineering Master's program.
Hi there, this is Nisarg Desai, studying in MN Civil with the Project Management first year.
Hello everyone, my name is Osasi Bunidu. I'm a first year ENGG program with specialization in energy and environmental engineering. Thank you.
Hi, this is Ashad, and I'll be presenting on the summary of the case. Formula One has been the pinnacle of motorsport racing, but has also seen tragedies reminding us of what happens when safety gets overlooked. The case focuses on two incidents, the first one occurring during the '94 San Marino Grand Prix, where Ayrton Senna, lauded for his aggression, crashed due to a poorly modded steering column that broke mid-race. This modification, which wasn't properly tested, ended up costing him his life. 20 years later, Jules Bianchi suffered a fatal crash at the Suzuka Grand Prix. Despite heavy rain and poor visibility, the race went on, and his car collided with a recovery vehicle on track. Eventually, Jules lost his life 9 months into intensive care. Both cases emphasize one thing: when safety is compromised, whether by engineers or stakeholders, the consequences can.
Okay, thank you for passing it over to me. So in this very particular session, we will be revealing the cognitive personal belief or the subconscious bias. So what we are going to do on this very session is that we want to explore how personal belief and decision-making bias influence engineering action. And what we did in this session also is to frame it around engineering ethics, virtual ethics, the role of uncertainty. We review how personal assumption and risk tolerance can lead to ethical oversight in a high-pressure environment. Next slide, please. So the point we'll be looking at in this session is one, the overconfidence and illusion of control among engineers, the normalization of risk culture under performance pressure, the status quo. Next slide. Next slide. Okay, when we say overconfidence and illusion of control among engineers, what does it mean as regard to this case study? When the engineers believe that they could push boundaries and make risk despite limited validation, that overconfidence contrasts sharply when core engineering ethics, where the protection of life must outrank performance ambitions. Next slide, please. 2. The normalization of risk culture under performance pressure. Repeated exposure to danger lead to unconscious acceptance of hazard as just part of the job. That undermines the virtue ethics, the virtue of prudence, courage, and moral clarity that get eroded when risk become routine. Next slide. Now, status quo. When we say status quo, when conditions change rapidly, in this case, the heavy rain, or the track hazard, the modified component, the decision maker defaulted to protocol rather than re-evaluating based on uncertainty. This shows that uncertainty doesn't excuse inaction, rather it demands a heightened ethical judgment. I will now pass it to the next presenter. Thank you.
Thank you, Osas. Now I will explain the system issues present in F1. So F1 is an internationally acclaimed event in racing which is organized by FIA. FIA has some flaws in system on ethical grounds such as less transparency, abrupt changing in decisions, and promoting the commercialization over safety. The last issue is common in all the cases which are studied by us, especially in Bianchi's case, where the race was forced to be conducted despite two crashes on the same track before him, as well as the rain was going on. So this shows the importance of safety, which is there and not there in F1's officials. Recently, in Qatar Grand Prix, the drivers were suffering from the scorching heat, but the race was not stopped. Moreover, the races are organized in the disturbed regions due to for expanding, but it is a serious issue for lives of the stakeholders. Issues are Misguiding technological neutrality. F1 claims that they are technologically neutral, but they are not, as some players are trying to get the results in their favor, such as McLaren, who was involved in 2007 Spygate. It is also applied to the Senna's team, as they tried to modify their car in order to win, but it resulted in Senna's case, fatal crash. Next is less inclusion of technically sound people in management decisions. This results in the fatal crash, as people are technically sound, but they are not able to go against managers. And last but not the least is less weightage to physical and psychological issues to driver, which is directly affecting in their performance. Now I request my friend Asad to take over.
These are the key lessons learned from the two cases. From Senna in 94 to Bianchi in 2014, we can emphasize about the importance of three core values: responsibility, innovation, and safety. Responsibility shows how choices made in high-stake environments carry ethical and moral consequences. Innovation shows how ethics shall lead the design process, which leads to innovation. Lastly, safety should be the foundation of every design and race decision, not just an add-on. These lessons also highlight that ethical responsibility is shared. Engineers working on car design must act with professional integrity, documenting and communicating where necessary. At the same time, the FIA must create systems and policies that support those ethical choices, not compromise them for performance or cost. In the end, Formula One proves that ethics must guide innovation, as was the case with the introduction of the Halo in the 2018 season, which led to lives being saved of two notable drivers, Romain Grosjean and Zhou Guanyu. When engineers and stakeholders act responsibly, technology doesn't just push limits, it also protects lives.
Thank you, Ashit. Here we discuss the future steps to prevent similar outcomes. Rebuilding the engineering ethics in Formula One. Formula One's past tragedies, like the Bianchi's 2014 accident, has exposed the systemic flaws where performance pressures overshadowed the safety protocols. And hence, we can rebuild the trust and accountability through engineering ethics, and it must be recentered. As EPICA emphasizes, engineers must hold paramount the health, safety, and welfare of the public, and this principle can directly translate into the motorsport ethics. Engineers should have a duty and authority to stop unsafe operations. Considering the actions for F1, it should establish an independent safety oversight authority. It also requires engineer sign-offs on weather and track safety, also to promote ethical leadership training to empower questioning unsafe directives. Thinking about the systemic ethics and the sustainable future for F1, that is embedding ethics within the system of F1. Just like engineering organizations such as EPEGA in Alberta enforce ethical audits and professional accountability, Formula One could also implement a similar system-wide approach. An FIA ethical review board and an annual safety and justice audit. This ensures that ethical reflection happens continuously and it's not a reactive one. For the sustainable future of F1, they must consider people, planet, and profit as the triple bottom line. People, for them, it's the safety, which should be of utmost importance over the performance. And for the planet, Formula One's net zero 2030 commitment should go beyond the tailpipe emission, considering the life cycle impacts, the supply chain carbon, and ethical sourcing of materials. Also, when we consider the profit of F1, it should align with justice, ensuring profits are derived from ethical and sustainable technological process and not from exploitation and neglect. These are the references which we have used for the creation of this presentation. Thank you so much for listening to us.